Okay, our last example for our rational functions, number 4. We have our x squared minus 5x plus 4. I'm just going to factor that real quick to an x minus 4, x minus 1. In our denominator, we have that common trinomial factor, so I'm going to pull that aside, factor that out. And we have that x minus 4. So if we factor that completely, that trinomial of x squared minus x minus 6 factors to an x minus 3x plus 2. And then we have that factor of x minus 4. Now we have that common factor of x minus 4, which we can cross out, but we cannot ignore the fact that x equal to 4 was an original restriction on our domain. So we will have a hole in our graph at x equal to 4. And recall when there were holes in our graph, those common factors that we were able to eliminate, we would just take that value and plug it back into the simplified expression that we had, the simplified equation, to figure out the corresponding y value. So if I take 4 and I plug it into the simplified equation, I would have 4 minus 1 over 4 minus 3 and 4 plus 2. And I get 3 over 1 times 6, so 6, and I get 1/2. So we will have a hole in our graph at 4, 1/2. And I'm just going to plot that over here right now. So we are going to have a hole in our graph, and that is that 4, 1/2. Our vertical asymptotes for our rational functions, recall our vertical asymptotes are where our denominator is equal to 0. And so we have two values now with our simplified rational function. We have two values where our denominator would equal to 0. So we have two vertical asymptotes, one at x equal to 3 and one at x equal to a negative 2. So I'm going to sketch our vertical asymptotes in here. We have one at x equal to 3 and one at x equal to a negative 2. And recall, because we have two vertical asymptotes, we should have 3 branches of graph, 3 sections of graph. Our horizontal asymptotes, we want to look at our highest degree of x. So if we're looking at our simplified equation here of x minus 1 over the x minus 3x plus 2, if we were to think of that back multiplied out, so we would really have an x squared minus x minus 6, our highest degree of x is that x squared. So we have 0 x squared terms in the numerator, and we have a 1x squared term in the denominator. So the ratio of those coefficients is 0 over 1. So our horizontal asymptote is y equal to 0. So we have a horizontal asymptote at y equal to 0. So I'm going to sketch that in here. So we have our horizontal at y equal to 0. X-intercepts is where we always set y equal to 0, our function equal to 0. So our x-intercepts, because it's a fraction, is always where our numerator is equal to 0. And our numerator will equal 0 when x is equal to 1. So we have an x-intercept. Let me get a different color here. We have an x-intercept at 1, 0. So I'm just going to plot that, right there. And our y-intercepts our y-intercept is where we set x equal to 0. And if I set x equal to 0, I'm going to have 0 minus 1 over 0 minus 3 and 0 plus 2. And our y-intercept is a negative 1 over a negative 6, or a positive 1/6. So we have a y-intercept at 0, 1, 6. And let me switch my colors here. I'm going to put our 1, 6. We're just gonna kind of plot that right there on our y-axis. And then recall, we're going to look at behaviors. And we're going to look at behaviors as we approach any vertical asymptotes and as we approach any x-intercepts. And we had an x-intercept at x equal to 1. And so we're going to leave that factor of x minus 1 alone, and we're going to take that value of 1 and plug it into the other x's where that 1 did not come from, our non-zero terms. And so 1 minus 3 and 1 plus 2. And so we are going to get that behavior of x minus 1 over a negative 2 times 3 is what, a negative 6. So basically it's an x to the first. It is a linear with a negative coefficient. So our behavior as we approach that vertical, that x-intercept, is going to be similar to a negative sloped line. So it should be coming down. And so if I just, as we approach x equal to 1, our graph should be coming down in a negative slope line format there. At x equal to 3, which was one of our vertical asymptotes, x equal to 3, we're going to leave the factor of x minus 3 in the denominator. We're going to leave that alone because that's where the 3 came from. We're going to plug that value of 3 into the other x's, those non-zero terms. So 3 minus 1 up in the top in the numerator and 3 plus 2 in the denominator. And we're going to get 2 over x minus 3 and then times 5. So basically 2 over 5 x minus 3, or that is similar to a positive 1 over x graph. And a positive 1 over x graph is looking something along those lines. So as we are approaching that vertical asymptote of x equal to 3, a positive 1 over x on the right side of that vertical asymptote, our graph should be coming up. Our y value should be getting large, going towards a positive infinity. And on the left side of that vertical asymptote, our graph should be coming down because that is what a positive 1 over x, the behavior of a positive 1 over x, does. And for our last vertical asymptote at x equal to a negative 2, that came from the factor of x plus 2 in the denominator. So we're going to leave that factor alone. We're going to take that value of a negative 2 and plug it into the other x's where that negative 2 did not come from, the non-zero factors. So a negative 2 minus 1 and a negative 2 minus 3, and we're going to get a negative 3 over a negative 5x plus 2, or basically that's going to be a positive coefficient, a positive 1 over x. And a positive 1 over x, again, looks something along these lines. And so as we are approaching that negative 2, that vertical asymptote of x equal to a negative 2, our behavior should look like a positive 1 over x. So on the right side, as we approach that vertical line from the right side, a positive 1 over x should be coming up, going towards a positive infinity. And as we approach that vertical line on the left side, our behavior of a positive 1 over x should be going down towards a negative infinity. So if we combine those behaviors all together, we have this horizontal asymptote that our graph should be coming along that horizontal line as it goes towards a negative infinity. It's coming down along the left side of this vertical asymptote, going towards a negative infinity. On the right side of this vertical asymptote, our graph is coming up. It comes down through this y-intercept, down through this x-intercept, and then down along the left side of this vertical asymptote. On the right side of this vertical asymptote, our graph is going up towards a positive infinity, comes down, we have a hole in our graph at 4 1/2, and then it comes down along this horizontal asymptote as it goes off towards a positive infinity. Now again, our graph does not cross vertical asymptotes. It did happen to cross our horizontal asymptote here at x equal to 1, but our horizontal asymptotes, recall, as we go off towards a positive infinity and as we go off towards a negative infinity, our graph is getting closer and closer and closer to that value of 0. The distance between our graph and that horizontal line is getting closer and closer to 0. So our graph is approaching that horizontal line. The value of this fraction is getting closer and closer to 0 for very large values of x and very small values of x. So if we just come down here on the right-hand side, limits is something that you're going to look at next year, but just to kind of get an idea and looking at our graph, if we look at our function, our f of x, and as we look at the limit as x is going off towards a positive infinity, so as x is getting larger and larger, the value, our graph, is flattening out along that horizontal line. The limit is approaching 0. If we look at the limit as our x values are going towards a negative infinity, so as x is getting smaller and smaller, as our graph is going off towards a negative infinity, our graph is flattening out along that horizontal line. The value, the limit of that function is equal to 0. On the limit of f of x, as x is approaching a negative 2 from the left, 2 with that little negative means from the left. So as our graph is approaching this vertical line here, this x equal to a negative 2 from the left side, we can see our graph is going down. So the limit is a negative infinity. It's going down towards a negative infinity. Versus over here, when the limit of that function as x is approaching that negative 2 from the right side, well, as it approaches that vertical line from the right side, our graph is going up. It's going up towards a positive infinity. And down on the left here, the limit as x is approaching 3 from the left side. So as it is approaching this vertical line on the left side here, our graph is going down towards a negative infinity. Versus the limit as x is approaching 3 on the right side, well, on the right side, our graph is coming up. It's going towards a positive infinity. So just a little preview for some fun future things that you will be doing next year. And that, gentlemen, will end our fractional rational